Uh, Hello everyone. My name is Nyonzima Fabrice. We are majoring in electrical engineering and we are going to record two videos. One about a transistor which will act as a switch, and the next one it will be a transistor acting as an amplifier oscillator. Okay, let's get started. I'm going to share a Proteus screen with you so that you can see the process. Uh, okay, here is the screen of Proteus. So I'm going to build them. Uh, Going to pick the components that I will need. Let me look for a battery, a a resistor, and also an NP and a transistor. This one, bipolar silicon NP and low power bipolar transistor. And also we need a switch, this one, and also we need a LED. Let me take yellow LED. Okay, the components are enough, so let's start to build the circuit. Let me connect the components. Let me try to put them uh good press. And they also should supply uh, the current to the base. Okay, now we should set the value of our component. Let's this resistor set to 100. The battery, let's set it to 5 volts. And this resistor, let's set it to 2.2 kilo ohms. Okay, now our circuit is ready. Let's just try to simulate it, see if it's working. Our circuit is ready. As you can see, it's working. The transistor acts as a switch in this circuit. So my fellow student is going to tell you the function of each components in this circuit. Okay, go ahead.
The BA given 5 voltage is the resource of the power supply, and Q1 BC547 is the left side is the emitter and the right side is the collector resistor, and the D1 is the yellow LED light, and R1 is the resistor and 100 ohm, and R2 is the resistor also, is 2.2 k ohm. And the R1 is the connected in series with LED and prevent excessive current from the damaging the LED. D1 is the load that the transistor switch on and off. The Q1X is an electronic switch. When the base receives a small input current, it allows a much larger current to flow from collector to emitter, lightening the LED. R2 limits the current entering the base of the resistor, protects the resistor from excessive base current. Control switch, a simple mechanical switch placed in the base circuit. When closed, base circuit closed, resistor LED turn on. When open, no base current. Transistor cut off, the LED turn off. That's it.
Okay, thank you. Now the first circuit is finished. We are going to talk about the second video. This one is finished. Um, let's go through to the second one, which the transistor will act as an amplifier. And try to open it. So we have already with our circuit. We will try to explain so that you can understand. In our circuit, we have V sine, which will be a sine wave that this transistor will amplify with resistors and the capacitors. And also we have an oscilloscope, which will show us the output, which will show us the result for the input signal and the output signal. So here we have V sine, which will give us the sine wave, we should amplify. And that signal will pass through this C1 capacitor, which has 47 microfarad. This will act as a coupling capacitor. It will block the DC to pass through it, while it will allow the AC to pass. So that signal, it will be supplied in this transistor. But before that, we have two resistors, which are voltage divider resistors, R1 and R2. And also we have two other resistors, which will be, this one is the corrector resistor, and this one is a resistor which will remit the current to flow through this transistor. And we will get also a bypass capacitor and another one which will be a coupling capacitor, and also another resistor which will remit the current to this one. To the end, we will get a microscope. As you can see, everything is sorted. To the V side, I have set the values. Uh, when you have the amplitude 100 millivolts and the frequency is 50 hertz. So this is our circuit. Let me try to simulate it. Okay, everything is ready. As you can see, we have this one is input signal. You can see the sine wave of it is weak, but this one, the blue one, is the output signal, which is the one that we have amplified. I don't know if you see it. To this one, we have 75 millivolts. Let me try to put them. And to the second one, we have 1.58 volt. As you can see, the input signal is weak, while the second signal is strong, or is amplified. This one has small amplitude, while the second one has a big amplitude. Okay. Let me try to stop the simulation first so that my fellow students can tell you the function of each component. Okay, go ahead.
Okay. V1 AC input source provides the small signal AC input. This signal is what the amplifier, the boost. Q1 NPN transistor, the main amplifying device, operates in the active region to produce voltage and current gain. Biasing resistor network R1 and R2 is the voltage divider bias. Create a stable DC bias voltage at the transistor base. This sets the Q point operating point to ensure the linear amplification. R3 is a collector resistor. Convert the transistor's varying collector current into an output voltage signal. R4 is the emitter resistor. Its RE provide the thermal stability and improves linearity, reduce gain slightly by introducing negative feedback. R5 is the output load resistor, helps define the output impedance and stabilizes the output signal. The capacitors are C1 and C2 and C3. C1 is the input coupling capacitor. It blocks DC from entering the transistor base from the AC source. C2 is the output coupling capacitor. Blocks the DC from reaching the output load or measuring device. C3 C3 is the emitter bypass capacitor connected in parallel with R4. Bypasses AC around the emitter resistor, increasing AC gain. That's it.
Okay, thank you. So let me simulate it again so that you can see the output of it. As you can see, this is the input signal, and the second one is the output signal when it has already been amplified with the transistor. As you can see, the first one is weak, but the second one is strong. So that's all for our video. Hope you enjoyed the video and I hope you understood what we were sharing with you. So thanks for watching. See you in the next video.
Thank you.
Thank you.